Alain is next. Scott.
Our first speaker today is Alain Briancon. I hope I'm saying that right. Briancon. Okay.
Merci.
Yes. No, c'est deal there. Alain is Vice President of Research and Data Science at Dynata, where he oversees data science and research-driven innovation across market research operations, survey methodologies, and client solutions. He has 25 years of experience in artificial intelligence, data science, and enterprise technology, and has served as VP, CTO, and CEO in startups and Fortune 500 companies. So welcome to the stage, Alain.
Thank you. And thank you for putting this CDLI on, and I think for a bunch of us, Shana Tova. I was feeling comfortable starting, and then you reminded everybody of the high quality of the presentation from yesterday. So it's like, darn, now I've got to rise up to the opportunity. So it's going to be, I'm going to give you an insight about how we're thinking about synthetic data. It's going to be a little different than everybody else, but everybody is different. We're not yet all regress to the mean, so that's a good thing. And then propose a framework. It's the framework we're using to deal with quality of data and validation of results. And it's working for us, might be working for you. So there's a lot of discussion about synthetic data, and the first thing we try to do is to say it's a system, a series of systems. Synthetic data is a form of AI. There are multiple use cases we discussed yesterday. There is a tremendous dependency on the data scope. And when looking into when to adapt and not to adapt, evidently trade-offs need to be taken. So what we've done is we've analyzed 57 use cases. This was a series of interviews with customer, would-be customer, the next door neighbor, suppliers and the like, and we organize them according to this taxonomy, like dendrogram. And at the end of the day, the ones that are emerging as being more of interest are the ones that are listed here. They're the blessed 7. The difference between the underrepresented group, the boosting that a lot of people are asking on, and the unanswered or skip question is in one cases, you fill all the entries in the row. And in other cases, you only fill some entries. So some of the columns are being pre-filled and you've been putting them together. What has been more interesting, I've been with Dynata 6 months, is can you please synthesize this group we know nothing about? Right-handed oncologist from Eastern Ohio, very difficult to get. Can you synthesize them? And you have to be very politely to say based on what? Because if you understand the challenges of audience activation, this is a very difficult problem. So part of our approach has been to look at other uses of the potential technology. By the way, the L I just noticed stands for lots. What we've looked on is from a performance point of view and from a organization point of view, map those different use cases to see which ones the technology as it stands today. The today was probably a month and a half ago. So some blue might have gone to green. And Michael Douglas famously said that green is good. In this case, green is good. And as you can tell, there are a lot of use cases where the technologies are available to design system to fill the use cases that are listed. And in other cases, they're not available. And the one that you say under the top sampling and weighting functionality, which is typically in the middle of the survey fielding, from a life cycle of the survey point of view, is of course the right-handed oncologist from Eastern Ohio. So this is the one that everybody wants to. Not everybody, a lot of people want to do, but not available. But if the population slightly changes, and if you've got the data that allows you to relate the characteristic of this population with the population of interest, you move to a conditional ability to do so. And one of the takeaway from this is the ability to use synthetic data system depends a lot on the context and depends a lot on the range of data that you have and the interrelationships between the different elements in the data sets you'll be using for your synthesis. I'll just show the context dependent. This is, this is not the synthesis work is from a company we're working with, and we looked into a boosting example, and this was looking into intent to purchase a specific service. Some folks were reached by online through PC, answered the answer through PC, and the other one by cell phone. And so what we looked through a relatively straightforward cluster analysis is if we wanted to boost a specific element of the population that are the purples and wanted to use this boosted population for understanding purchases, we could do well. But if we try to figure out, does this give me the insight to reach a certain type of folks through the PC or through the phone, the computer for the phone, then it's not adequate. Same data, same series of questions, same answers exactly, but the purpose of how these results would be used, the fifth why to why you're doing this, why you're doing this, why you're doing this, in this case, allowed us to say in some cases it works and in other cases it doesn't. And that's a challenge. It's a challenge because if you focus on the technology, which is I'm about to do in a second, and you think only in terms of the answer to the surveys and the accuracy and the recall and the P factors and the like, but you don't take into account the purpose of the study, then you're going to be making mistakes. So this puts somewhat of a brake on rush. So the challenge is when you look into all those use cases, you cannot build a system that will synthesize them all. This is not the Lord of the Ring. You have to find a way to systematically compare results. You've got qualitative answers, you've got quantitative answers, and you have to find a way to compare them all, or at least put them into an equal footing. In commerce, we have dollars or francs, well, not anymore, euros and the like. You've got an equal measurement that allows you to compare things. And our approach is to look at information theory. Bits are bits. And if you measure the amount of information that something gives you and the amount of information that you need to make a decision, you've got somewhat of an equalized, uniform, maybe not intuitively understood by everybody, but something that allows you to compare things and to make decisions. The nice thing also is bits don't hallucinate. At least not yet. I haven't seen the neutron, so we'll see how it goes. What this allows us to do is to balance data versus algorithm versus purpose. Dynata sits on a ton of data. Algorithms can be developed, acquired, GitHub. My team already went to the 2,000 plus 500 because I told them on Friday we're having kind of I want to know what it is. So they're kind of lucky that Yom Kippur is on Thursday, so I don't bug them right away. But those things are available, but the purpose is what's going to allow us to deal with, to adapt it to the uses. So why information theory? Because we like norms. A reminder for those who have not dealt in it. So the entropy measures the uncertainty or the diversity of the data. The mutual information is how information about this data set or this subset of a data set relate to another one. And the information gain is the reduction in uncertainty that you have, or the increase in surprise, when you were talking about the rate-based test. And when applying those principles, we have found that it gives us somewhat of a uniform way to compare different elements, the data, the algorithm impact, the interrelationships of the data, and the purpose. So if you look into managing different sources of information, everybody is pretty much better than I am understanding the different categories. we can measure inherently the amount of bits, the amount of information that each one of them carry. And we can tell, which we knew intuitively from our experience, is that behavioral information answers to what happens when you've got specific events and how you react to it, carries much more information than, let's say, broad demographic information. What this analysis allows you to do is that if you look into the reaction to an ad, not whether I like the ad or not, but whether I'm going to do something because I saw this ad, my intention to purchase is going to be heightened and the like, is very difficult to predict because the mutual information that you get between what happens before this event and after is low. So without going too much into the weeds, this approach allows us to weight the importance of the different data set. There was great discussions on the dimensionality and the hollowness of some data and how you're able to use it. What you will notice is don't measure the amount of information that goes from text because inherently it's one, not a data sets that we have a lot of, and two, it's a little more complicated because of the impact of the embeddings on the element you get. The second element that I want to bring up is structural data structure. I know it's a tongue twister, are quite important. We all have dealt with structured data and unstructured data. What gives inherently a lot of informational content is structural relationships. Understanding the relationships between different elements is important. Under what conditions that a specific respondent respond at what time and the like. Why are they making this answering based on some kind of information about products and the like is important. And what this brings is this brings graph technology in the center of a lot of the analysis. Organizing the data using graph databases allows you to extract relationships and for new types of algorithms to understand the structural information behind your data set. And we think that this is a way to extract mutual information better than other approaches. When looking into, you have data sets, you have text that comes from a generic corpus. You've got a survey information and the like. What you have to be careful is if you try to have as broad of a framework as possible is to go beyond it. Latent variable you can think as meta behavioral, understanding common events. There was some great discussion on the Facebook, but we're on Facebook at $1,000, but I don't know if his offer to stop using it, but I don't know if his offer still holds this morning. Willing to go to 900. Cultural shifts, events, COVID, tariff, have impact, and you need to find a way to model them. The challenge is that they have very low entropy. So they have a lot of mutual information, typically between the event itself and what happened afterwards. And then you've got confounding variables. Someone take Tylenol, and we know all the controversy. Well, the good thing about all this controversy is that it really explains the difference between, in many places, between causality and correlation, and what is a confounding variable. So you need to understand things very well. One of the most challenging areas we've encountered is if you've got people who are exposed to competing advertising from multiple companies, is the exposure to the other guy's advertising at times is a confounding variable on what you have now. So if you try to synthesize this, and this is the reason it's a lower priority from an execution point of view, things become very, very challenging. So you've got this way to synthesize different data for different uses and the like, and then you decide what to do with it. If you look purely into accuracy, and I use a loose definition of the word accuracy, you're probably missing part of the decision-making process, because we start from, as a guiding principle, the purpose, the why of the why of the why of the why of what you're doing the study. And you're going to get some operational tolerance. Making the decisions to set a new plant the operational tolerance is minimal. The economic impact is very high. So when looking into making decisions, you need to understand for different purposes and for different data sets where you're going to be on this dimension. And I think those are pretty self-explanatory. There are some techniques that are more difficult to integrate than others. Privacy protection is one that I want to bring up. We have, and other survey and market research company have, the answer to surveys from multiple companies. When does training a system based on this agglomeration of data, when is it legit or not? You can read the TOS if you want to, and you have to be careful. But ethically, you have to be very, very strict with respect to having information about the survey for a specific company being applied to the learning to something that might help others. And this is where structural data is important, because the structural information from a survey or set of surveys or the market condition associated with a specific company are going to be at times different enough that if you inject them in the proper manner, you're going to be able to develop this system while preserving important private information from different customers. And that's, in our mind, extremely important. Couple of applications of this framework. Hopefully the slides I'm not going to read through it. We can have a discussion later on. And what we've done is we show how you can apply this decision-making process, this decision approach to the different use cases that I mentioned before. And that allows you a priori, before you look at the data set, before you look at the purpose of the study, to decide which technique to use and which ones are going to be likely to be successful and not successful. One of the challenges in bringing this technology to market is to find a way to, ahead of a trial, to get a sense if this is going to work or not. Trial and error is a good thing at times. Trial and terror is not. So this is why, for instance, we're focusing a lot on the optimizations of the survey design, which, when you use graph technology, is interesting because you can start looking into what are the proper way to stem questions, as well as pre-wave work. 5 minutes. Tech choices, yes. You can use some techniques to do quantitative, and it works great. Depends on what is the purpose of the use. And what you see here is we like a lot of things. The one thing we don't like systematically, and I know that LLM is very popular, is directly tune LLM, where you take the entire data set, you have a base model, then you're going to lower it based on information that you got on specific customer, on your specific data set. In our case, that will be the survey. And we think that, one, it's data hungry, computation intensive, but it forces you, in order to get a certain amount of performance, and I use again the word accuracy in a very, very loose terms, it forces you to at times cross the border between different studies from different customers. And this is something to be avoided at all costs. So what we like a lot is what we call structural LLM, which you can translate, I mean, for this audience, I can translate to graph plus RAG plus tuning. And we think that the capture of the structural information through the graph and RAG side is the way to go through it. And yes, at the top, I did put imputation. And the reason, if you want to get people to feel comfortable about something, says then you've been doing it all along. This was a subtle rebranding exercise. This is not the synthetic data you're looking for. This is the synthetic data you're looking for. Very, very bad use of Star Wars here. Why structural over tuned? There's a lot of discussion in LLM. Don't hear me wrong. We like LLM. We use it parsimoniously, and we use it in targeted information. This is not the Swiss Army knife for synthesis. There are many other cases where it works. You can get good performance at the quantitative level when you do boosting if there is the right data set that you are working with. And by the right data set, it means that when we go back to our framework, the mutual informations between right-handed oncologists from East Ohio and doctors in Ohio, if there is enough mutual information that can bleed from one to the other, bleed's probably the wrong term, especially, that can go from one to the other, then you are able to make it work. And that's the difference between, in the multicolor diagram matrix, between a red and a blue. And the challenge is you have to understand the purpose, the fifth why in why you're doing this, and your original characteristic of the data set to say, it's gonna work here and not work there. And developing those kind of guidelines we see as essential as a way to get people comfortable with this technology. So on this, so we like structure, and we think that especially when you've got rare segments, this structural information that goes in front of the LLM allows you to do better work, and it insulates customer by design. We think that this, but the privacy, people spend a lot of money to do this work. We have to make sure that they do not inadvertently help their competition. And I think there's that slide. So what are we doing? We're building and adopting, and when necessary, license a set of synthetic data systems based on the fundamentals I highlighted, and delighted to work with others in putting those things into place. Thank you.
Thank you so much. I had a quick question. I know that you mentioned you're using for both qualitative and quantitative and seeing some good results. I'm curious to understand a bit better, like which of the two have been seeing more success?
I would say it's about 2/3 qual, 1/3 quantitative, but we don't perform generic analyses. It's saying these are typical, e.g. the accounts that sales tells us it should be interesting to do something and then work through it. The most challenging in this space is if you want to have very precise price in which people are going to be buying a product versus another, versus if it's between this and that, in this between this and that, what you do, which I know is a little straddling between the two. But if you look into conjoint analysis on steroids and all extension thereof, and we think that synthetic data works quite well. When applying it to the, I don't know where this goes, to the pre-wave work, which is, sorry, we find both of them to work typically extensively. So when you look into the optimization of the survey design, as well as in the pre-wave, which are going to get one day, not yet, we see that both of them work quite well. So this is not as much one working better than the others, it's one working into where you are on the cycle of the design and the kind of functionality that you're looking to do, looking to perform.
Thank you. And one quick follow-up question. So when you do have, like you said, usually qualitative is doing a little better. Do you tend to sort of convert the qualitative to quantitative measures for your own sake when you're doing that? What kind of working backwards, or just kind of leave it open and qualitative?
We measure the informational content that this has. It becomes, when you go to embedding, where you reduce the dimensionality, it's a little trickier to compute, but the point of the matter is you're doing this projection while keeping the informational content. So at the end of the day, we attempt to measure everything in terms of bits. Even, for instance, the p-factor. A p-factor of 0.05 is like 3 to 4 bits, depending on the situations. If you go to 0.0001, it's 10 bits. So Then you can assign, you can do this answer and then multiply by an economic tolerance or an economic impact and work through it. So far, it has been a good lingua franca to compare different elements. The challenge is it's good for the geeks in the lab, guilty, but when you present that to customers, we have to find a way to present the information in which significance is more understood. And this is where explaining that you need to have a decision matrix, you need to have a spider diagram to get the element, allows you to navigate through it. Statistical accuracy, loose term, is only one of the many components you need to consider. This also allows us to avoid getting dropped. How does it compare with the ground truth? It has to compare to the ground truth, but it doesn't have to be perfect with respect to the ground truth, because what matters is the application of the insight you get for the type of studies you're doing and for the purpose of that type of study itself.